Welcome back to my YouTube channel. In the previous video, I explained on how to come up with the equilibrium constant expression. Now in this video, I want us to look at on how to calculate the equilibrium constant. Now there are some few things we need to know about the equilibrium constant before we get to start calculating, because using the equilibrium constant, they can ask you to say if the reaction is going to the right or if the reaction is going to the left. Okay, so the size of the constant, if is greater than 1, when the constant is greater than 1, it means that the rate at which the product are being produced is faster than the rate at which the reactant are being used. Okay, so in this case, we are going to have a lot in terms of concentration, a lot of products compared to the reactants. Okay, that is when it is greater than 1. But when it is very big, for example, if it maybe the constant is about 20, 30 and above, it shows that the concentration of the reactants are heading towards the compression, meaning they are almost used up completely. Okay, they're heading toward the completion. Now, when the constant is less than 1, meaning negative numbers, it means that the amount of reactants will be greater than the amount of the product, which means that the reaction is going this side. Okay, the previous one, the reaction was going this side. So in this case, the reaction is the reverse, is going this side, which will increase the amount of the reactants than the amount of the product, which means that the rate at which these reactants are being used up is less than the rate at which they are being formed. Okay, meaning that we're going to have a lot of these than the products. Okay, so that is about the constant. So the value of the constant can help you to say which one is favored. Is it the forward reaction, or is it the backward, or the reverse reaction? So having in mind on how to come up with the the constant, the equilibrium constant expression, the same idea is the one we want to apply on this question. Okay, so calculate the equilibrium constant for the following reaction based on the concentrations of we have PCl5 is equals to 0.030 mole per liter, and PCl3, which is equals to 0.97 mole per liter, and Cl2 is equals to 0.97 mole per liter at 300 degrees Celsius. Okay, then we have been given an equation here. Now always, as I said earlier on, for you to calculate the equilibrium constant or the equilibrium expression, for you to come up with it, you need to balance the chemical equation. So this one is already balanced. As you can see, we have one phosphorus, then 5 chlorine, also 3 plus 2, 5 chlorine. So it's balanced. So the constant equilibrium, you first have to write the equilibrium expression. So write the equilibrium constant expression. That's the first thing. Equilibrium constant expression. That's the first thing you need to do. Okay, so we say the equilibrium constant is equals to the square. Start with the product, remember. So we have PCl3 to the power, the coefficients there is 1, but if you want, you can just leave it out. No, anything to the power 1, it is the same thing. Okay, so multiply by the Cl2 to the power, the coefficients, which is 1, over the product, the reactant now, which is the PCl5 to the power 1. Okay, now since we want to find the equilibrium constant of this using the concentration is given, then we have to start substituting the concentration on each substance here. Okay, so this will be the equilibrium constant is equals to what is the concentration of this compound. You go back to the question. So this is PCl3. So PCl3, the concentration is 0.97. Okay, then to the power 1. Okay, then power 1, just get rid of it if you want. Then the concentration of chlorine, which is 0.97, okay, to the power 1 as well, because of the coefficients there. Over, we have the concentration of PCl5, which is 0.030. So 0.030. Okay, again, this is also to the power 1. Now you can get rid of the powers if you want, because 1 does not change a thing. So you simplify what is on top first. So 0.97 to the power 1 is the same as 0.97. So 0.97 times 0.97. Okay, so we have, hope you can see. So 0.97 times 0.97, we will have, okay, so we have is equals to 0.9409 over 0.030. Okay, so the answer which you have found, divide by 0.030, which is giving us 31. So the answer is equals to 31.3633, which is the same as 31. So the equilibrium constant is equals to 31. Okay, so this is how we find the equilibrium constant in terms of concentration. So the equilibrium constant in terms of concentration is expressed by, the product over the reactant. Always don't forget that. Okay, now if you look at this question, the value of the equilibrium constant simply means that the reactant, in this case the PCl5 decomposition, the rate at which is being decomposed is faster than it is being formed. So the forward reaction has been favored, which means that the rate of reaction is going to the right side. Okay, thank you. Now let's solve the last question. Okay, so I have another question, similar question here. Calculate the equilibrium constant for this reaction. Is the forward or reverse reaction favored? Okay, this is the reaction, and we have been given the concentration there again. So this is nitrogen monoxide, which is equals to 0.050. Then we have oxygen 0.75, and nitrogen dioxide, this is monoxide dioxide, 0.25 moles. Okay, same thing, come up with the the constant equilibrium, the equilibrium constant expression first. So we have the constant equilibrium concentration. This must be small as a subscript, so the constant equilibrium concentration is equals to, in terms of the we start with the product first. So the square brackets, we have nitrogen dioxide to the power, the power is the coefficient, which is 2. Okay, we only have one product there, over, we have nitrogen monoxide to the power 2 times the oxygen to the power 1. Okay, so you get the concentration for nitrogen dioxide. So the equilibrium constant is equals to, what is the concentration for nitrogen dioxide? Is 0.25. So 0.25 mole over the concentration of nitrogen monoxide, which is 0.050. Okay, then to the power, what is the coefficient? It's 2, so to the power 2 multiplied by the concentration of oxygen, then to the power 1. Okay, so I forgot the power, so the power 2. So the constant, the equilibrium constant is equals to, what do we have? 0.25 squared. So we have 0.25 squared. Okay, so to the power 2 is equals to 0.0625 over, you simplify these one by one as well. Simplify these one by one. Oh, instead of oxygen there, put 0.75. 0.75. Okay, I'll write it here. So 0.75 to the power 1. Okay, so over 0.050 squared. Okay, 0.050 to the power 2. What do we have? Okay, we have 2.5 times 10 to the power -3. Okay, then times, again the same thing, so a number to the power, it is itself, does not change, so 0.75. okay, then you have to multiply this at the bottom so that you can divide it later with the number on top. So the equilibrium constant is equals to, you say 2.5 times 10 to the power 3 times 0.05. So the answer which I had found here times 0.75, which is giving us so on top we still have the same 0.0625 over what we have at the bottom now, 1.875 times 10 to the power 3. This is the same as it has a 3 decimal, there's 3, you have to move 3 times from the decimal point, 1, 2, 3. So this is the same as 0.001875. okay, so if it can be difficult for you to divide, but it can't be difficult since we're using the calculator, it's okay, you can use it the way it is. So you say open the brackets, then you write 0.0625, close the bracket, divide by, open the bracket, we have 1.875 times 10 to the power -3. Then close the brackets. The answer we're going to have is, okay, the answer we'll have is K, the constant, equilibrium constant, is equals to, we have 33.333, which is the same as the equilibrium constant, is equals to 33. Okay, so now there are two questions there. You calculate, and now you need to determine if the forward or the reverse reaction has been favored. So you can see that the constant is greater than 1. So which means that the forward reaction has been favored. The reaction is going to the right side. Okay, so thank you for watching. This has been Joshua Webster. Help me to make more videos by recommending. Don't forget to subscribe, share the video, and like. Thank you so much for watching. Have a good day.